Good morning, everyone. I'm Himanshu Vasnani from Department of Mechanical Engineering. I'm here to present a lecture on the subject Material Science. Subject code is ME207. We are studying unit number 2, and lecture number 9 in this series. Today's topic are alloy steel, design consideration, and key behavior of materials. So, today's learning objective is to provide the student with a basic understanding of alloy steel, general consideration in designing a machine component, key behavior of materials. And the outcome will be students will have an understanding about alloy steels, general configuration designing a machine component, key behavior of materials, and they will understood various parameters of general consideration designing a machine component, key behaviors of metals. It is in various stages how creep takes place. So for now, we're starting with the alloy steels. See, an alloy steel may be defined as a steel to which elements other than carbon are added in sufficient amount to produce an improvement in properties. We cannot see metals, they appear in pure forms also, but every application is not suitable to use the metals in the pure form. So we need to obtain a desired improvement in the properties of the materials for a particular application. For that we go for alloy steels. The alloy steels, it is defined as a steel only to which elements other than carbon are added in sufficient amount to produce an improvement in the properties. So the alloying is done for specific purposes to increase the wearing resistance, corrosion resistance, and to improve electrical and magnetic properties, which cannot be obtained in plain carbon steels. The chief alloying elements used in steel are nickel, chromium, molybdenum, cobalt, vanadium, manganese, silicon, tungsten. Each alloying element has a specific properties, has a specific, you can say, um, qualities or X factor, which are helpful in providing an improvement in the properties of the steel. Okay, because what is an alloy steel? Alloy steel will be defined as a steel to which elements other than carbon. So these are elements are other than carbon are added in sufficient amount. Depending upon the requirement, we will decide the amount to produce an improvement, to produce an improvement in properties. So these are different elements like nickel, chromium, molybdenum, cobalt, vanadium, manganese, silicon, tungsten. These all are added. These all elements are added in defined quantities or amounts to produce an improvement in the properties. Okay, these elements. Okay, nickel, chromium, molybdenum, cobalt, vanadium, manganese, silicon, tungsten. Okay, we are naming a few. It may be more than that also. Each of these elements confers certain qualities upon the steel to which it is added, and these elements may be used separately or in combination to produce the desired characteristics in the steel. But I told you just in the starting only that this combination, this whole process is done to produce desired properties or characteristics in steel. Okay, so then we are talking about each element, each alloying element that we'll be using in individually. Okay, then following are the effects of alloying elements on steel. The first one is nickel. You can see in the diagram how the nickel looks like. Okay, then it increases the strength and the toughness on the steel. This nickel is increasing the strength and toughness on the steel. These steels contain 2 to 5% nickel and from 0.1 to 0.5% carbon. And in this range, nickel contributes great strength and hardness with high elastic limit, good ductility, and good resistance to corrosion. The purpose of nickel is to provide strength and toughness of the steel, and which it is doing. Okay, an alloy containing 25% nickel. See, this is giving you various percentage of nickel and what it will impart to the alloy. Okay, now an alloy containing 25% nickel possesses maximum toughness because its reason is to provide strength and toughness. So here 25% nickel, an alloy containing 25% nickel will possess maximum toughness and offers great resistance to rusting, corrosion, burning at high temperature. Okay, and it has proved to be an advantage in the manufacture of boiler tubes, valves for use with superheated steam, valves for IC engines, and spark plug for petrol engines. Depending upon the percentage of nickel in the alloy steel, you can understand that its applications, it's very useful. Like for spark plug of the petrol engines, it is be used in that. Valves for IC engine, boiler tubes. So this range of applications require a material which has high toughness and has great resistance to rusting, corrosion, and burning it at high temperatures. So nickel is an important alloying element. A nickel steel containing 36% of nickel is known as invar. So it has nearly zero coefficient of expansion. So it's in great demand for measuring instruments and standards of length for everyday use. So nickel has a great contribution as an alloying element in steel, and we should know that. Okay. The diagram, it's just a diagram showing how a nickel looks like. Okay. So you can see in the diagram how nickel, how it is looking. Okay. Then chromium. You can see in the diagram how chromium looks like. Okay. Now, regarding chromium, it said that it is used in steel as an alloy element to combine hardness with great strength and high elastic limit. See, it has its own alloying, its own properties. Okay, it will impart hardness with high strength and high elastic limit. Then it also imparts corrosion resisting properties to steel. The most common chrome steel contains 0.5 to 2% chromium, which is a good amount, and 0.1 to 1.5% carbon. A chrome steel is used for balls, rollers, races for bearing. You can see in the bearing, you can in the balls and rollers and races, chrome steel is used. Okay, because chromium provides corrosion resisting properties to steel. Okay, so it's really good thing. It's a good alloying element for steel. A nickel chrome steel containing 13.5 2% nickel and 1.5% chromium and 0.25% carbon, which must use for armor plates. Okay. Then chrome nickel steel is extensively used for motor car crankshaft. I repeat, chrome nickel steel extensively used for motor car crankshaft axles and gears, requiring great strength and hardness. So chromium is also important because it is giving you corrosion resistant properties, which is making them helpful in one of the most common application that is called as bearings. Okay, this is an important alloying element for steel. So next, tungsten. You can see in the diagram how a general tungsten looks like. Now, tungsten has its own properties. It is giving you a property that it will remain hard at high temperatures also. So, tungsten is unique in its properties. Now, you can study that it prohibits heat when heated to red color. Understand? It is giving you a property that it will remain hard. The workpiece will remain hard even when heated to red color. So it is a very good property. Then it is usually used in conjunction with other elements. Steel containing 3 to 18% tungsten, 0.2 to 1.5% carbon is used for cutting tools. You can understand the cutting tools. Cutting tools are used for machining. So you can understand that it should be hard. And tungsten is imparting hardness to that material, to that cutting tool. So it is a very good alloying element. The principal uses of tungsten steel are for cutting tools. I once just given an example the steel containing 3 to 18% tungsten, 3 to 18% tungsten, and 0.2 to 1.5% carbon is used for cutting tools. The principal use of the tungsten steels are for cutting tools, dies in which you go for castings, valves, taps, permanent magnets. So it has its own applications And the common application is that steel containing 3 to 18% tungsten and 0.2 to 1.5% carbon is used for cutting tools. So this has its own importance, its own applications. Then vanadium. Vanadium, it aids in obtaining a fine grained structure in tool steel. The addition of very small amount of vanadium, less than 0.2%, produces a marked increase in tensile strength and elastic limit in low and medium carbon steels without a loss of ductility. Okay, you understand that a small amount of vanadium is helpful in increasing the tensile strength and elastic limit in low and medium carbon steels. And ductility is also not lost. So this vanadium in a very small quantity is very helpful. The chrome vanadium steels containing, now it is giving you some examples that what it will impart, how this alloying element is helpful to steel. The chrome vanadium steel containing 0.5 to 1.5% chromium, 0.15 to 0.3% vanadium, 0.13% to 1.1% carbon have been extremely good tensile strength, elastic limit, endurance limit, and ductility. You can see small amounts of addition of alloying elements is providing such variety of strength to this kind of steel, which is called as chrome-vanadium steel. So this is appreciable when you talk about alloy steels. See the role of each alloying element in steel. Now these steels are frequently used for parts such as spring, shaft, gears, pins, and many drop force parts. So this has a varieties of applications. You can see the diagram how vanadium looks. Okay, then manganese. You can see in the diagram how manganese looks like. Manganese it provides the strength of the steel. It improves the strength of the steel in both the hot rolled and heat treated condition. I repeat, manganese it improves the strength of the steel in both hot rolled and heat treated condition. The manganese alloy steel containing over 1.5% manganese zero point 0 to 0.5%, where high strength combined with fair ductility is required. Okay, so this alloy, alloying element known as manganese, this also has its applications. Okay, it contributes a lot when you talk about manganese alloy steels. Like just given an example, the manganese alloy steel containing 1.5% manganese with a carbon range of 0.4 to 0.55% are extensively used in gears, axles, shafts. So you can see that this has its applications. The principal use of manganese steel is in machinery parts subjected to severe wear. These steels are all cast and ground to finish. Okay, so this manganese also has its role. Okay, the manganese alloy steels contain over 1.5% manganese with a carbon range of 0.4 to 0.55% are used extensively in gears, axles, shafts. So this is an important alloy element. Then we go with the silicon. The silicon steels behave like nickel steels. Okay, these steels have a high elastic limit as compared to ordinary carbon steels. Silicon steels, these silicon steels containing from 1 to 2% silicon and 0.1 to 0.4% carbon and other alloying elements are used for electrical machinery. Understood, electrical machinery, valves and IC engine, springs, corrosion resisting materials. So you can see that how silicon steels are helpful and how this alloying element is contributing to produce different kinds of applications like electrical machinery, valves in IC engines, springs, corrosion resisting materials. Okay, then cobalt. Cobalt is also an important alloying element. Okay, it gives red hardness by retention of hard carbides. I repeat, it gives red hardness by retention of hard carbides at high temperature. It tends to decarburize the steel during heat treatment. It increases the hardness and the strength, and also residual magnetism and perceived magnetic force in steels for magnet. Okay, so main is it tends to decarburize the steel during heat treatment, increases the strength and hardness. So cobalt as an alloying element is very important as for like all other alloying elements. Molybdenum, in a very small quantity, you can see 0.15 to 0.30% of molybdenum is generally used with chromium and manganese. Manganese is 0.5 to 0.8% to make molybdenum steel. Okay, these steel possess extra tensile strength and are used for airplane fuel switch and automobile parts. It can replace tungsten in high speed steel also. We understand that how it is, you can say, providing them certain side stream. Okay, a small quantity, maybe 0.15 to 0.3% of molybdenum is generally used with chromium and manganese, that is 0.5 to 0.8% to make molybdenum steel. So you can understand that these all alloying elements like nickel, chromium, manganese, silicon, cobalt, molybdenum, tungsten, these all have their roles where they impart some or the other useful properties when they prepare an alloy and alloy steel with the help of these all alloying elements, which are somewhere helpful to a particular application, which is imparting a particular application in the field of production, in the field of machinery. Okay, so alloy steels have their particular roles. Then we go with the design considerations. See, following are the general design consideration designing a machine component. Okay, while designing a component, there are some points that should be considered. Okay, so we are discussing all the points as an overview so that you have a general idea of how uh, how what point should be considered. Okay, like the first one is the type of load and stress caused by the load. Okay, you can say that the load on a machine or a machine component may act in several ways due to which the internal stress are set up. So first of all, we should know that type of load you are taking and the stresses caused by the load. Okay, so that you will understand that how this is affecting and producing internal stress. Okay, and the second is motion of the parts or kinematics of the machine. Okay, how the different parts of the machine they play their role or what is the kinematics of the machine, that is the linkages. You can say the successful operation of any machine depends largely upon the simplest arrangement of the parts, which will give the motion required. See, there is a motive behind every machinery, that is to achieve the required motion. And if that requirement of, that is the motion, is achieved by simply arrangement of the parts, then it is the best policy to achieve the successful operation of any machine. So this motion of the parts, so the successful operation of any machine depends largely upon the simplest arrangement of parts which give the motion required. The motion of the parts may be rectilinear motion, which includes unidirectional and reciprocating parts. These motion of the parts may be either rectilinear motion, which includes unidirectional and reciprocating motions. Okay. Then Second is the curvilinear motion, which includes rotary, oscillatory, or simple harmonic. Then is constant velocity, and the fourth is constant or variable acceleration. So this four kinds of motion are shown to you that whichever way the machine may operate. So I repeat once again, the successful operation of any machine depends largely upon the simplest arrangement of the parts which will give the motion required. Okay, so the motion of the parts, that is the arrangement of the machine, is also very important. Okay, then we'll go with the third. So till now, 2 points are okay. Then what kind of load is applied and how, what are the stresses caused by the load, and secondly, the motion of the parts. Third is selection of the material. See, material play a very important role, and their behavior also play a very important role, because when the material is in use, so under working conditions, the behavior is important. Okay, so selection of material is at par very important when you talk about design considerations. Whenever you will talk about design consideration, selection of material will play a very important role, and it depends upon the designer. So it is essential that a designer should have a thorough knowledge of the properties of the materials and their behavior under working conditions. Like now, in the previous slides, we studied about various alloying elements which were helpful and can be used in alloy steels to provide a certain set of properties. If they are used properly based upon the experimentation, if they are used in proper percentage, then they may be used to give, to provide, to impart certain extra, you can say, properties to the alloy steel and make its functionality unique. So the selection of the material is very important, and for this important work, the designer should have a thorough knowledge of the properties of the material and their behavior under working conditions. See, some of the characteristics of material are like strength, durability, flexibility, weight, resistance to heat, resistance to corrosion, ability to cast, welding, harden, machinability, electric connectivity, etc. These all characteristics should be known to the designer, and from which material these various properties are linked, so that it is able to select the proper material for the required part or machine. Then form or size of the part. You understood selection of materials? Okay, this is one of the very important, you can say, design consideration. Whenever you talk about design consideration, selection of material is very important. Then form and size of the parts. The form and size are based on judgment. Okay, the smallest practicable cross section may be used, but it may be checked that stresses induced in the design cross section are reasonable. See, you can design a part of any size. Okay, but whatever size you are choosing, it should be usable. Secondly, the stresses that are induced in the part in the design cross section, that should be safe, because if that is unsafe, then it is of no use. Then it is of no use. It may either break down or it may either not function properly. So you should understand that for proper functioning, it should be checked. Okay, because if the size is not proper or the formation is not proper, then automatically it will break down or it will not work properly. So the form and size are based on judgment or based on the past experimentation. The smallest practical cross section may be used, but it may be checked. I repeat, the smallest practicable cross section may be used, but it may be checked that the stresses induced in the design cross section are reasonably safe. Okay, In order to design any machine part for form and size, it is necessary to know the forces which the part must sustain. Okay, because it should be checked that the stresses induced in the design cross section are reasonably seen. So it is also important to anticipate any suddenly applied or impact load which may cause failure. Okay, we have to avoid failure or we have to find out the limit at which the failure may occur. Okay, so the form and size of the parts is important. Okay, because if by mistake, if suddenly any load is applied, then it may lead to failure. Okay, then the frictional resistance and lubrication. See, there is always a loss of power due to frictional resistance that we all know. And it should be noted that friction for starting is higher than that of running friction. This is also known at the starting, the friction is higher. And when it is running, then friction is comparatively smaller. So it is therefore essential that a careful attention must be given to the matter of lubrication of all surfaces which move in contact with one another, whether it is rotating, sliding, or rolling. So here, while designing, we should know that what is the friction resistance it is offering in the starting and running also. And the various, you can say, supporting elements are lubricated or not. Because lubrication is very important for all the parts, either the rotating parts or the sliding parts or the roller wheel. Okay, everything, every part is important in this. So lubrication should be properly done for all the rotating parts, sliding parts, and rolling wheel. Then convenient economical features. See, in designing, the operational features of the machine should be carefully studied. The starting, controlling, and stopping lever should be located on the basis of convenient handling. Whatever we are designing either for machining and secondly for convenient handling. If convenient handling is there, then operating will be really easy and output will be better. Okay, so the starting, controlling, and stopping levers should be located on the basis of convenient handling. The adjustment for wear must be provided employing the various take-up devices and arranging that so that the alignment of parts is pre-resolved. Okay, I repeat once again. The adjustment for wear must be provided employing the various take-up devices and arranging them so that the alignment of parts is pleasing. Okay, now if parts are to be changed for different products or replaced on account of wear or breakage, easy access should be provided and the necessity of removing other parts. I repeat, the necessity of removing other parts to accomplish this should be avoided if possible. Okay, we saying that if there is a part that is to be changed for different products, or rather it should be replaced due to wearing or breakage, then for that purpose, easy access should be there. The arrangement of parts should be so such that it should be easily accessible for replacing or repairing, and the necessity of removing other parts to accomplish this should be avoided. It should be arranged in such a way that other parts are not removed and the part which is weird or rigged or had a breakdown, it can be easily removed or replaced. Okay, the economical operation of a machine which is to be used for production and for the processing of material should be studied in order to learn whether it has maximum capacity consistent with the production of goods. Okay, so every machine should be economically used to have the most economical operation for the machine that is used for production. Okay, so that it can give you a maximum capacity. Okay, consistent with the production of good work. So that it has maximum capacity consistent with the production of good work. Then is use of standard parts. Okay, the use of standard parts is truly related to cost because the cost of standard or stock parts is only a fraction of the cost of similar parts made to order. So the standard or the stock parts should be used wherever possible. Parts for which patterns are already in existence, such as gears, pulleys, bearings, and parts which may be selected from regular shop stock, such as screws, nuts, and pins. The bolts and studs are should be as few as possible to avoid delay caused by changing drills, reamers, and taps, and to decrease the number of wrenches required. So you should use standard parts and avoid such kind of unwanted things, so that you can say proper usage is there, and the designing is very easy. Then you understood this kind of point, no? Use of standard parts. Okay, it should be very carefully done. Then safety of operation. Some machines are dangerous to operate, especially those which are speeded up to ensure production at the minimum. See, our motive behind all designing of parts, all alloying of this, all production, all manufacturing is to ensure production at a optimum rate. Okay, so we know that for some machines to produce good production, these are dangerous to operate because some are speeded up to ensure production at a maximum rate. Therefore, any moving part of a machine which is within the zone of a worker is considered an accident hazard and may be a cause of an injury. You know that in the workshop also you have that impact testing machine. So what we do when we go testing for the ISO or Charpy test, we usually draw a boundary while you can say operating the lever, you can say releasing the lever. Why? Why? Because we know that the operation of the machinery, it may be harmful if someone is standing in front of the you can say machine. So we draw a safety zone, a barrier all around the machinery, which is giving you a safety of operation. That movable part on the impact testing machine will not harm the people nearby or the operator while operating. So in this way, you can go for safety of operation. Okay, these so machines should be designed in such a way that they are not dangerous to operate. Okay, because any moving part of a machine which is within the zone of a worker is considered an accident hazard. I repeat, any moving part of a machine which is within the zone of a worker is considered an accident hazard and may be the cause of an injury. So it is necessary that a designer should always provide safety devices for the safety of the operator. Okay, because safety of the operator is the you can say basic you can say point to be considered for a designer also. Okay, but the safety appliances shouldn't show no way interfere with the operation of the machine. Both should take care should be taken. Both care should be taken. Like the designer should design such a way that the safety of the operator is ensured, and the safety appliances should be applied in such a way that it will not interfere with the operation of the machine. So both the purpose are achieved. Okay. Then workshop facilities. A design engineer should be familiar with the limitations of his employer's workshop in order to avoid accidents. So sometimes required is necessary to plan and supervise the workshop operations and to draft methods for casting, handling, and machining parts. See, we should know that what kind of work should be done in the workshop. So it should be designed in such a way. Okay, so somehow, sometimes it's necessary. Sometimes it's necessary to plan and supervise the workshop operations and to draft methods for casting, handling, and machining special parts. The number of machines to be manufactured. This is also an important design consideration. And a number of articles or machines to be manufactured affect the design in a number of ways, like the engineering and the shop cost, which are called as the fixed charges or overhead expenses, are distributed over a number of articles to be manufactured. Okay, and see this is depending upon how to you can say fix the cost of a particular parts. So you can understand that there are some fixed costs. or overhead expenses. So these all costs are not total imparted on one article. It is distributed over a number of articles to be manufactured. So if any few articles are being made, then extra expenses are not justified. So unless the machine is large enough some special design. So an order calling for small number of parts or small number of products will not permit any undue expense in the workshop process. So the designer should restrict his specification to standard parts as much as possible. So number of machines we manufacture, this also has an important design consideration. Then comes the cost of construction. The cost of construction of an article is also a very important design consideration. Like in some cases, it is quite possible that the high cost of an article may immediately bar it for further applications, considerations. Okay. Then if an article has been invented and test of, you can say, handmade samples have shown and that it has commercial value, then it is not possible to justify the expenditure of a considerable sum of money in the design and development of automatic machines to produce the article, especially if it can be sold in large number. Okay, then I repeat. Let's see. You should consider the cost. Okay, like suppose if an article has been invented and tests of some handmade samples have been shown that it has commercial value. Whatever we are doing, it is going for a commercial value. And it is then possible to justify the expenditure at a considerable sum of money. This is also good. In the design and development of automatic machines to produce the article, okay, you have justified the cost, especially if it can be sold in large numbers. If the large, you can say, output is there and there is a good return of sum of money, then every expenditure can be justified. So the cost of construction is also very important while designing anything. The aim of design engineer under all conditions should be to reduce the manufacturing cost to the minimum and obtain maximum profit. Okay, so we should reduce the manufacturing cost to the minimum. Understood this cost of construction? Okay, it is a very important kind of a design consideration for design engineer. Then assembling. See, every machine or structure must be assembled as a unit before it can function. Large number, large units must often be assembled in the shop, tested, and then taken to be transported to their place of service. Okay, see, everything has to be tested. So before assembly, one should test and everything, and then taken to their required place. The final location of any machine is important, but before then, testing should be done. And design engineer must anticipate the exact location and different facilities for the connection. So in this way, assembly is also important. So we have studied about all the design considerations that a design engineer should take care of, and each factor, each design consideration has its own importance. Okay, each factor, each consideration has its own importance, but the motive is to produce part in the best possible way, to produce part in a safer way, to produce part in with minimum cost of production. So if you achieve or if you plan in such a way that all such points should be covered. Okay. Now there is a topic where called as a creep. We will be studying about that. That creep, you can say that it is a kind of a deformation. Okay. A deformation which is time dependent and deformation which is permanent in nature and a deformation which when subjected to constant load or stress then it comes into existence. Okay, so this is an also an important topic that is called as skilling. Then as shall be started. Okay. Then we should start the creep now. Materials are often placed in service at elevated temperatures and exposed to static mechanical stresses. Okay, like turbine rotors in jet engines and steam generators experience centrifugal stresses and high strength streamlines, high pressure streamlines. So deformation under such circumstances is termed as creep. Okay, when the materials are they are used at elevated temperatures and exposed to static mechanical stresses. Defined as the time dependent and permanent deformation of materials when subjected to a constant load or stress. creep is normally an undesired phenomenon. It is not desirable thing. It is undesired. But if proper, if negligence is there while determining the stress, then this can take place. Sleep is normally an undesired phenomenon and is often a limiting factor in the lifetime of a part. It is a kind of a limiting factor. So we can say that it is observed that in all the material types, for all in metals, it becomes important only for temperature greater than about 0.4% of absolute melting temperature. Okay, so it is about 0.4 into absolute melting temperature. So this is an important. Okay, so we should understand that creep, it can be defined as a time dependent or and permanent deformation of materials when subjected to constant load or stress. Okay, it is a kind of a undesirable phenomenon, but we have to take care of it. If we are understood that if we can identify that, okay, where is the constant load or stress is applied, then somehow we may avoid it. But for now, we should understand what is creep. The generalized creep behavior. A typical creep test that consists of subjecting specimen to a constant load or stress while maintaining the temperature constant. Deformation or strain is measured and plotted as a function of elapsed time. Over the time, you try to find out that what kind of deformation is happening with the specimen when the specimen is subjected to a constant load or stress. Okay, and maintaining a proper temperature also. So in this way, you are able to find out the creep behavior, how it works. Like I'll show you a diagram showing the creep behavior of metals. So if you in this, what happens? There is a load applied and there is a deformation. So you can see that there is a graph showing a creep curve, which is called a creep curve, which is, you can say, drawn with creep strain versus time at constant stress and constant elevated temperature. Okay. Then the minimum creep rate, that is delta E upon delta T, okay, is the slope for the linear segment in the secondary region. So rupture lifetime, TR, is the total time to rupture. So here you can see that the total time that is shown as TR at which the rupture takes place. So you can see that how the deformation is happening in three stages. That is a primary, then secondary and tertiary, and the creep rate at different stages. Okay, so this is how the creep is studied. Okay, and the resulting creep curve, which consists of three regions, that is the primary or transient creep curve, the secondary creep, and the third is tertiary creep. Okay, let me check how much time do we have regarding this. Okay, I think that we should start with the MCQ because we have to understand all things. This I'll continue later on in the other lectures. Okay, there are also temperature effects on this and how the testing is done. Okay, we have a good amount of material. Okay, now we will start off with the MCQs. The plastic deformation of metal takes place when the stresses induced in the metal due to the applied force has reached the, you can say, when does the plastic deformation takes place? When it has reached the yield point. Okay. Then in creep curve, which is the following stage is known as the unstable stage. It is called transient creep stage. Okay. Then in the creep curve, which is the of the stages, do we observe a constant deformation state? It is the steady stage, creep stage. In the creep curve, in which of the following stages do the deformation rate increases and causes failure? That is the fracture stage that I showed in the diagram also. Then you can go the specific body of material or a series of alloys with the same composition is known as, go with the thing, system. Okay. Time dependent yield. Okay, that's the difference. depending upon the time. It is known as creep that I just told you when we were studying creep. Okay. The metal fracture is more dangerous than the tile fracture. Metal fracture is more dangerous than a tile fracture because it doesn't give any warning signs. The propagation takes at very high speeds and no need for extra stress during fracture. All points are considered. Okay. And nickel increases the strength and toughness of the steel. Whether this point is true or false. So you can say it is true. Then chromium. Chromium is used in steel as an alloying element to combine hardness with high strength and elastic limit. So what do you say? Is it true or false? We have studied about chromium. I have shown you that what is the importance of chromium in alloying steels. Why do we use it? So it is giving you to that combines hardness with high strength and high elastic limit. Do you think it is true or it is false? Understand the question. It is used to combine hardness with high strength and high elasticity in steels. So it is true. So the following is a slow rise of plastic deformation under the action of stress that I discussed just with you. This is free. So in this lecture, we studied about all the alloying elements, all the design considerations for design engineer, and a small portion of creep, giving you just an idea of creep. In the coming lecture, I'll explain you in detail about creep, action of creep, how it happens in all the three stages, and what things can be done in order to avoid creep. Okay, see, there are things which are important, but these are time dependent. It happens with the evolution with time. So we should understand. So we should understand that okay, some things are time dependent, and we should have some patience to understand them. And if we understand, and if we and or you can understand, if we rather know the reasons which are responsible for such kind of deformation, if we know the reasons which are responsible for such kind of deformations, and if can be avoided, then the factors like creep can be avoided. So here in these references of this subject, there are these kind of textbooks which are good in their field, and if you want to have more knowledge regarding these topics, you can refer these books. These books are available in the library, and most important thing, if you want to go with detailed study of all the topics that we have discussed right now, you should go with these books. See, books are friends, so you should try to read. Your reading ability will increase your knowledge. So try to read books. Try to create a habit of reading. It will increase your knowledge, your vocabulary in the subject. It will increase your style of thinking. Okay, you will get a better in-depth knowledge of the topic. So try to read books, try to understand, try to develop a habit of reading. Okay, so try to develop a habit of reading. Okay, so thank you all for now. And I repeat once again, try to develop a habit of reading. So till now, I have tried to explain the best that I can. And I repeat once again, try to develop a habit of reading for sure. So guys, thank you all for today.